with the criminal networks, the networks that are involved in crimes. My thesis, I am Andres Perez Coronado, and my thesis advisor are Henry Laniado and Gustavo Canavire. Okay, the outline for today is problem statement, justification, state of the art, theoretical framework, research objective, methodology, and contributions. Problem statement. Right now, crime events and crime networks are really related, are linked. And this picture just is to show how this graph is relating around the world, how criminal networks are linked between them, and they produce a lot of crimes in different points. And this is the crime scene do not cross, because it's the police officers and states should or must investigate these crimes. So they are related. The idea is criminal events and criminal networks are related, of course. For criminal approach, crime is an action or mission what constitutes an offense and punishable by law. If doesn't in law, some crime that doesn't in law or right in law, it doesn't matter for us. Sorry, we don't take in account, we don't use. The criminal is an individual who's committed a crime. And organized crime is a structure of criminals whose primary objective is to obtain money through illegal activities. Just we are gonna speak about organized crime that they follow money. The crimes that are political crimes, racial crimes, and they don't follow economic issues. We don't use. But what is really the problem in mathematical approach? The space-time crime events. Let us consider a data set of crimes type T. This could be homicide or murders or thief or loan sharking, small loan sharking like or drug trafficking, and every point occurs in a point P, that is R squared, that belongs to R squared. R squared here is longitude and latitude. The distance between the points Pi and Pj, where each one represents a crime event type T. It means that each crime has a distance. It's a delta ij equal to delta Pi and Pj. It means that we have some distance between this crime, even doesn't obligatory of no mandatory that should be Euclidean distance. We need a distance between these crimes. The Euclidean distance often used in the literature is not suitable to capture the dependence between point I and point J. It means the distance or the geographical distance in meters, kilometers, in others measures doesn't matter between the relation between 2 points, Pi and Pj, even if they are the same crimes. An example is in the, no sé, La Candelaria in downtown Medellin. We can find a thief, but it doesn't mean that the thief is in the same location or even around 200 meters or an epsilon at 300 meters. That means that these two crimes are very close geographically, but maybe they don't have the same structure of dependence between the points. We are gonna explain after that. I'm gonna explain, but the distance doesn't mandatory be the Euclidean distance. Space-time criminal networks, the graph G, VE, that vertex and edges is in a set, that criminal network data set, whose primary objective is to obtain money through illegal activities. V is a vertex of criminals, and E are edges or connection between them who commit that crime, and point P. This point P, that is line is R square, belong to R square, latitude and longitude. We find how they are related, the crime with the criminal event, what we can predict the occurrence, so we can understand how criminal networks are involved in this crime. We assume that GVE, this is a subgraph of a whole criminal graph. We say that because our data set and police and the state instrument and technology don't have the capacity to get every criminal in the world, every criminal in the city, every criminal in a country. So we just get a small part of a whole criminal graph. So we have V sub I and E sub I belong to GVE, a point within datasets. And we got already a graph that have a timestamp and location, and graph is related to the crime type G that belong to P. That means we have criminals that make several crimes. They make drug trafficking, murders, sexual exploitation, trafficking of guns, and they have several. This criminal network has several crimes at the same time, and each crime have a different P. That is the location. We define the vertex and space-time criminal networks is in prediction. We define three types of the vertex and their own edges. Known the vertex V sub K and known H A sub K that we have already in our data set. This is we get the data set and we say, okay, we have some vertex and edges, and we can plot a graph and we can understand and measure this kind of thing that is happening inside the graph or the network. We have already a known vertex and a known edges that the data set has not their characteristics well defined. We have some criminals, some vertex, and we have some connections that we don't know. We can't find who they are, what kind of criminals. So what is the name of criminals? But they are in my data set, and hidden vertex and hidden edge that we are not sure. This is just, we are gonna calculate by a probability if they exist or they doesn't exist in my graph, because we can say that is like out the sample. We should understand whether they are or they are not. They follows to the research question. Can a parametric statistical model predicts criminal events and the incidence of the networks involved? It's like non-parametric methods can help me to get how criminalism will happen and the incidence of this network that produce crime, that make crimes or felonies. And with my thesis director, we propose two hypotheses. First, past criminal events committed in a specific space and time entail the occurrence of criminal events. F, analyzing criminal records using non-parametric methods, then the future crime will be predicted. And this is for events. And the second hypothesis for the criminal networks is in an active criminal network are involved in criminal events. The vertex involved in future criminal events will predict if we characterize the known and hidden vertex and edges. So we should make some type of math and statistical and econometric models to give characteristic to a known vertex v sub u and hidden vertex v sub h. The justification of my research is on societal issues. Of course, if we are victims of a crime, the criminal events have an impact in rights of people, and to get context about some current issues, what happened right now, and how my rights as people, as person, as citizens is affected by the criminal events. Organized crimes will continue to promote profit in political cause, and they are connected worldwide, around the world. Even we can say that a small criminal organization have too much connection around the world, and we have to understand that. And we have just a small quantity, a subgraph of the whole criminal network, and we have to suppose, to predict by probability how we can find what are the connections between the criminal Colombian networks and the networks around the world. And Latin American Caribbean is the most violent region in the world, with a more than at the rate at 24 per 100,000 inhabitants in 2015 is the latest study. And you know, this is very important issue in our country to reduce the violence and crime. The question of policy new challenge will arise, and we hope to have the policy in the law enforcement agencies and the state to answer these questions. Where and when will the crime happen? What crime type will occur, and who will commit the crime? A state of art. We have some and different approaches that already institutions, researcher and are studying just right now. We already know that crime are more likely happen to a space-time where victims, attackers, and absence of protective elements converge. We identify patterns as useful tool for effective policy and creation of security. Even social media like as Twitter has potential for predicting crime, that we have involved different data to models. Hotspot mapping technique relies to the assumption that location of past events are good predictors. With the concentration of a lot of crime, we can predict that in the future will happen the crime again in the same place or at the same point P. Kernel density estimation key KDE and Twitter producing a prospective risk map with interpolates for crime location found in a specific area of interest. We can measure the risk terrain modeling and identify the vulnerabilities in improving crime prediction with KDE, the kernel density, because it's a non-parametric. This tool is non-parametric statistical, and they have a good performance. The standard work and outperforms disadvantage discussed using historical crime records and Twitter data located in geographic areas. Is a mix between KDE and Twitter to mix. Is a work on Matthew Herbert that we took to use in our project. Spatial statistic predicting policy in predpol support the decision-making process, increasing base of intelligence. They use big data, an algorithmic and software solution, geostatistics that support the decision system and use the covariance of metrics to modeling the structure of dependence. The most important thing in geostatistics, this is this covariance that make the structure of dependence of the all crimes, and even the crimes and other variables. The aerial approach of spatial statistics resembles to geostatistics and focus research in the results and related analysis, econometrics, and the main difference between geostatistics and aerial is geostatistics is in continuous space, and in aerial is discrete. Sorry. Criminal network, we find as well in a state of art of criminal network, delinquents benefit from being friends on another criminals. I mean, they are connected and acquire a proper know-how on crime business. They don't just are connected by make crimes, but to get knowledge about the crime. Economists have made some theoretical and empirical advance, understanding how networks operate, they work, they connected, and they make evolution at time. We know already for our experiments that criminal networks are scale-free. That means that a small vertex has a lot of connections and distribute power law. And of course, these kind of networks have an evolving models or evolving networks models that capture the mechanism to the tiny evolution of the network. Already to get hidden vertex and hidden edge, or a known edge or a known vertex, like I spoke a few minutes. Machine learning have a lot to find that. They incorporate deep neuronal networks and other time of crime in reconstruction of corrupted criminal network that we don't have too much information. We can predict the links between vertex, and of course this machine learning apport a lot to make this model. And right now we are going to speak about theoretical framework. That is the theoretical base. We are going to use kernel density estimation to find P as a total number of crime, and of crime P, and P is a spatial point, like I say, latitude, longitude, and H is the bandwidth. EK is non-negative function that integrates one. It's a density function. They take 1 point and it made like a bump in over each point, and it makes the map for each point and how they make the density, and between each point with other point. And the most important thing here is to get the best H. The bandwidth, it means how is my connection, or how is the space that I gonna take in account. H tell me, okay, I gonna speak about myself, or I gonna try to speak around other people. It's like the example, and the H is very crucial, very important for a KDE. The inverse distance squared interpolation is a technique to find the unknown points in predicting criminal events. Just we make an epsilon around 500 meters, that is WI, and we found, or I give more importance or more value for people or points, for points that are close to me. The closest points to me, I gonna give more value, and the larger or no close to me, I gonna find a small value. even here the distance is very important, because I can give for people that is close to me an Euclidean distance, or we can give that in Mahalanobis distance. That means it's not close to me by meters of kilometers, is close to me because we resemble, we are similar, these points are similar. So if this point is similar to me, I give more value, and is no similar to me, I give less value, a minor value. So in the Mahalanobis distance, if we use this distance and we make already some approaches, even if they point at very close, they don't have they are no, sorry, in Euclidean distance they are too close. Even in Mahalanobis distance they are not too close, could be other more, could be other closer. So this is really important, and we made really good approaches about that. And it is because we watch here that they take in account the covariance matrix, the inverse of covariance matrix here. The semi-variogram is taking account the same. The variogram just take the regionalized variable z, that could be homicide or murders, and this variable intrinsically stationary random function depending on vector h. It means that equal the h is the key to find this can have relation in this specific geographic area. Is my point plus an h, and if this h I have relation with other points. And this semi-variogram is the geostatistic. I should go deeper in this time in semi-variogram and Kriging, because these kind of courses are really difficult to find in Colombia, and information about that to get a course is really hard. But right now I am studying that in Kriging and co-Kriging. This is an interpolator, and to find the prediction of unknown points as well, and they use the variogram. And ordinary Kriging, that is the most useful or most familiar concept, is that it estimates points value with a region for which a variogram is known, and using data of the neighborhood of the estimation location. And this information they put together information, and the really interesting in Kriging and co-Kriging is that we can use socio-demographic variables and other kind of variables, not just the criminal variables. For that, we will wanna use the shrinkage of covariance matrix and spatial econometrics. The transformational sample covariance matrix, we are gonna tend to better estimate the covariance matrix and give this structure of correlation between variables of different types. Like I say, I can make relation between thief and murders and personal injuries. But in this with shrinkage of covariance matrix, I can use these three types of crime T that occurs on point P with poverty, Gini coefficient, and other information that I can get. Network graph, like I explained, a GV is a subgraph, the subgraph G, of the whole criminal graph Y. We assume that G is a hidden vertex, has a hidden vertex with hidden edges. And we are gonna try to characterize the predict what vertex would be involved in criminal events, as well as predicting the V sub K and V sub U, the V known and V unknown vertex that would be involved. I'm gonna try to find, okay, a murder will happen at point P. The criminal network that is delinquent or is working over there are, I don't know, graph G, the network G. So I'm gonna I'm gonna predict what kind of vertex will be involved in this murder, and it's really interesting. I hope that I I can understand really good in English. And time series, because crime events and crime networks, it will happen over time and time. And in our experiments, crime events, it changed by time and by place, of course, but in graph it happens in the same way. Maybe for September and October, drug trafficking is better crime, or is more frequently crime. So in the January and February is traffic of guns, of sexual trafficking. So we have that the criminal networks, it'll happen with different crimes as well of criminal events. And we are gonna use, or we try to use one where we are exploring the non-parametric functional data analysis, that in functional data, and we can make a lot of functions to find the better option. We try to use bootstrap aggregation or bagging to do that. And non-parametric regression, that is use a kernel, is a continuous probability distribution function. The parameter h column bandwidth is similar with the use kernel as well, and controls amount of smoothing. So we can make a non-parametric regression. We are using Nadaraja-Watson regression, and of course we can use the similar like KDE. My research objective is to design a non-parametric statistical model for the space-time prediction of criminal events and the incidence of the network involved. Is design this parametric model that we can make the space-time prediction of crime events, and to find how the network are involved over these crimes. My first specific objective is to propose a non-parametric set of methods for space-time prediction of the criminal events based on police data as called to the emergency phone number and documented crime. Second, to improve a spatial statistic method using shrinkage of the covariance matrix for the spatial time relation between different types of crimes. And third, to develop a predictive framework based on networks analysis to characterize the vertex involved in criminal events. The second objective, I will try to put together a lot of variables, not just variables related with crime, like emergency calls. We try to use socio-demographic variables like poverty, like Gini, like whatever variable that we find useful to the project, and to try to understand how they are related on the field. And the third, how the field receive or are affected by criminal networks. Methodology to review available literature. Space-time prediction is the first in non-parametric methods, density, regression, Mahalanobis distance, and joining the qualitative data of support in prediction. For instance, intelligence data calls to the emergency phone number of documented crimes. And we will review the spatial statistic technique of variograms and kriging, and it could be useful to put together a lot of these variables in approach to shrinkage the covariance matrix of all these variables. The phase 2 review literature in econometric graph theory and neuroanalysis and machine learning using to perform space-time predictions to predict, of course, I repeat, but hidden vertex and edges. And we will prove several algorithmic approximation. We are gonna try what is the best algorithmic approximation to get that, because is a lot of data, and they use a lot of computation as well to make this kind of processes, and will be useful to law enforcement making decision process. We tried to that this data could be used in the Colombian law enforcement. And phase 3, make a report, the research report of the phases 1 and 2, and design a doctoral thesis documented at least one submitted manuscript to EASY or Scopus ranked journal. We say that, and the contributions right now, a partial contributions, is first in Southwestern meeting of mathematical and applied mathematics. We present a poster in Cali with the advance of using Mahalanobis distance in interpolation process. That was good. And my contributions outlook is a new model based on non-parametric statistics that predicts spatial temporal crime events. The model will implement a statistical distance and statistical methods as Kriging and with shrinkage of covariant matrix, a framework network for space-time prediction of vertex to find what vertex will be involved in a crime at point P, and the methodology tested with computational issues tool using real Colombian law enforcement data that we already got. We already get that, we right now we don't have problem of data to run off models. And thank you very much. I hope your feedback, and thank you.
Thank you very much, Andres. I really would love to have some comments from the other students before I introduce my own comments to your presentation. Thank you very much.
Thank you.
Hola Andrés, qué pena, puedo